Hello everyone. So today we'll be discussing the solution of some of the questions of the test of limits, continuity and differentiability. So let us start with the first one. In the first question, they have told you to find this limit x tends to a minus, that means left hand limit, and then mod x cube by a minus greatest integer of x by a whole cube. So a in the question is given to be less than 0. So in your exam, you can always assume this as a number in your head. Let's say it is -2. So since the number is negative and you are approaching it from the negative side, so the number is x is still negative. So mod x will be -x. So this will be -x cube over a. And what will be this quantity? So let's say you are approaching -2 to the from the left hand side. So it is -2 point something, right? So again, if you divide it, sorry, -2, then -3. So it is still minus 2 point something. So -2 point something divided by -2 is still going to be something 1 point. So now this will be -1. And then if you calculate, you will get it as -a square -1. So option B. Okay. Second one, this is given in terms of cos. So limit n tends to infinity. So cos x by 2, cos x by 2 square, cos x by 2 cube, and so on up to cos x by 2 raised to n. So how will we write this as? This is a cos formula from trigonometry, cos a, cos 2a, and so on. So we will consider this 2 raised to x by 2 raised to n as a. So what will be write the next term is basically we are reversing this entire series. We are starting from the last. Next term will be 2 raised to n minus 1. We can write that as 2 raised to n times 2. Next will be cos x by 2 raised to n times 2 square. So where will it end? It will end at x by 2 raised to n times 2 raised to n minus 1 because it starts with x by 2. Okay. So now what is the formula for cos a, cos 2a and so on? You have to figure out the number of terms first. Since it is ending at n minus 1, number of terms is n. So sine 2 raised to n, 2 raised to n a. What is a? X is this a is x by 2 raised to n. And divided by 2 raised to n sine a. This. So this cancel. And how do I solve this question? Sin x will be basically constant for this limit. So we can take it out of the limit. The remaining is this. We can write this as 1 by sin x by 2 raised to n and divided by x by 2 raised to n times x. Just to make it in the form of sin x by x. So what will be the answer to this? This one will become 1. So the remaining is sin x over x. So option C. Okay. Let us see the next one. In the next one, they are asking you limit again related to greatest integer. Third question. So limit theta tends to 0 n times sine theta over theta n times tan theta over theta. So there is a very important property for very small angles. It is sine theta less than tan theta. For quantities very close to 0, which is exactly this case, theta tends to 0. So now if you apply this, we can write it as sine theta by theta less than 1 less than tan theta by theta. So what will be the left hand limit? Let us calculate the right hand limit first because it is easier. Theta tends to 0 plus positive quantity. So all of that sine theta by theta and then n tan theta by theta. So since sine theta by theta is less than 1, so n times something less than 1, 0 point something, it will make this a quantity which is just less than n. Any number which is just less than n, what is the greatest integer of that? It is n minus 1. Let's say 2, you multiply it by a very small number. It becomes something which is very minutely less than 2, 1.9 something. And what is the greatest integer? It is 1. So 1 less than 2. So that is why 1 less than n. And for the other one, what will be the answer? Now this quantity tan theta by theta is greater than 1. It is 1.000 something. If you multiply 2 by 1.00 something, it will cross 2, but just somewhere very close to 2. So what is the greatest integer of that? It is 2 itself. So for here, it will be n itself. So the answer is 2n minus 1. For the second one, that calculation will be exactly the same, because sine theta negative, it will become minus, and theta itself is minus. So minus by minus will again become plus. So this quantity will still remain 2n minus 1. So 2n minus 1, left hand limit also. So which one will be the correct option? Option C. Left hand limit and right hand limit are both same. Let us look at the fourth question. Limit x tends to 0. Greatest integer 1 minus e raised to x times sin x by mod x. Okay. Now we will have to calculate the left hand limit and right hand limit separately. Left hand limit. You are approaching to this function. X is approaching to 0, but from the left. So right now it is a negative number which is very close to 0. So minus 0 point something. X raised to 0 minus. First of all, let us write the mod x as minus x. Okay. So x tends to 0 minus means where will this quantity go? We know that e raised to 0 is 1. So e raised to some quantity just less than 0. It will be a positive quantity, but it will still be 0 point something. So this will go to 0 plus. It will remain positive. And what about this sin x by minus x? Sin x by x tends to 1. So it is minus, is there one more symbol? So that will be, it will be going to 1, but from the negative side. Okay. So going to 1 from the negative side, from the left hand side means still 0 point something. And this is also 0 point something. Two quantities which are still 0 point something, and you are multiplying it. So that will be still 0 point something. Again, one minus symbol is there. So the quantity which is here now shifts here. Okay, because of this minus symbol. So what will be the left hand limit of this quantity? Very close to 0 from the left hand side, minus 1. Okay, let us calculate the right hand limit now. X is going to positive side, after 0 from the positive side. So what will be this 1 minus e raised to x? Now it is not e power minus 0 point something. It is e power 0 point something. Okay, since e raised to 0 is 1, e raised to 0 point something will be something which is greater than 1, because base e is greater than 1. So this will be 0 from the negative side. This will be a negative quantity. Again, this sin x by x will be what? It will be going to 1. But since it is right hand limit, so sin x by mod x, right? So mod x will be x itself. The only difference between this and the previous one is that this symbol and this quantity. So going to 0 from the negative side, fine. And then again going to 1 from the positive side. So if you multiply, you will still get a number which is minus 0 point something, and then this will be minus 1 still. So both of them are same, and which option will be the correct option? Option A. Let us look at the fifth question. So in the fifth question, they have given trigonometry divided by some algebra, x raised to 4. How do you solve this? The most commonly used way of doing this is using expansion. So cos sin x minus cos x raised to divided by x raised to 4. X tends to 0. What is the expansion of cos x? It is 1 minus x square by 2 factorial plus x power 4 by 4 factorial. So in place of x, it is sin x. So in the series also, in place of x, we will just write sin x. So 1 minus sin square x by 2 factorial plus sin power 4x by 4 factorial. And this minus 1 minus x square by 2 factorial plus x4 by 4 factorial and so on. This whole divided by x raised to 4. Now sin x again you have to expand separately. But you have to only expand up to the terms that are actually useful. In the denominator, we can clearly say that there is x raised to 4. So in these terms also, we will only write terms up to x raised to 4 and ignore all the higher powers. So 1 minus 1 by 2 factorial. We can clearly see that this 1 and then minus this 1 will get cancelled. So we can cancel it in this step itself. Let us not write it. So remaining is this, and what is the expansion of sin x? X minus x cube by 3 factorial plus x raised to 5. We don't need to write x raised to 5. We don't want it. So square. Okay. Plus 1 by 4 factorial. Here we will only write x because the next term is x cube. Raised to power 4 will be 12. We don't want that power. So let us keep it as it is. Okay. All the other terms are not our concern. So here this will be x square by 2 factorial minus x power 4 by 4 factorial and so on, divided by x raised to 4. So now here it will be limit x tends to 0. Now again we have to expand and collect as many terms up to x power 4 as possible. So this is minus half, and this quantity, if I do whole square, one of the terms that I'll get will be x square. The other term here, b square, will be x raised to 6. Again, not our concern. So we'll not write that. But minus 2ab will give me x raised to 4. So that term I'll write. So minus 1 by 3 x raised to 4. Okay, using a minus b whole square only here. Okay. The rest terms, again, not our concern. Plus, from here, the only term that I need is the first one, x raised to 4. So 1 by 4 factorial x raised to 4. Okay. And then plus x square by 2 factorial minus x raised to 4 by 4 factorial. Again, this will be cancelled. We don't want that. Okay. So overall, what do we get here? There is a division here. X raised to 4. Okay. So again, we see that this minus x square by 2 plus x square by 2, again they get cancelled. This and this will also get cancelled. The remaining is only this x power 4. So the coefficient of this in the numerator will be the answer. What is the coefficient? Minus 1 by 2 minus 1 by 3. So 1 by 6. So which option is correct? Option B. Yes. Let us look at the next question. The sixth one. Limit x tends to pi by 2 sin x minus sin x raised to sin x divided by 1 minus sin x plus ln sin x. There are too many signs here. So obviously we have to take y as sin x. We will solve this by substitution. So if x goes to pi by 2, then sin x will go to what? Sin x will go to 1. So y will go to 1. What is the term now? In place of sin x, we are writing y. So this will be 1 minus y plus ln y. So we can clearly see this is a 0 by 0 case. So what to do in the case of 0 by 0? We can use the L'Hopital rule. 1 minus. What is the differentiation of y raised to y? This is something that you should remember as a formula. It is y raised to y times 1 plus ln y. And what is the differentiation of the denominator? It is very easy. It will be minus 1 plus 1 over y. Again, if you see, this is still 0 by 0. So if I just differentiate it once, what am I supposed to get? This will become minus y raised to y 1 plus ln y whole square minus y raised to y times 1 over. What is the differentiation of the denominator? Minus 1 over y squared. So now this limit y tends to 1. Overall, I can write it as y square y raised to y 1 plus ln y whole square plus y raised to y minus 1. Now no problem here in substituting 1. We can easily substitute 1 here. So what will we get? 1 and then 1 plus 1. So 2 is the correct answer. So this will be B. Let us look at the next question, question number 7. This is also a very good question. You can clearly see in the expression that is given in the limit, it is entirely in terms of sign except for this tan square x. Okay, except for this tan square x. So 2 sine square x plus 3 sine x plus 4 minus square root of sine square x plus 6 sine x plus 2. Okay. So again here we have to put sine x as, let's say, t. So what will this limit become now? T will go to 1. Tan square x can be written as sine square x by cos square x. So t square by 1 minus t square. Okay. So here we can write 2t square plus 3t plus 4 minus t square plus 6t plus 2. Now there is a irrational term here. What do we do in case of irrational terms? We do rationalization. So we will multiply by this replaced with a plus. So if we multiply, then we will get something like this. This will the squares roots will open. You will get cancelled by the squares. This will become 2t square plus 3t plus 4 minus t square minus 6t minus 2 divided by square root of 2t square plus 3t plus 4 plus t square plus 6t plus 2. So limit t tends to 1. What will the numerator become in our calculation? This becomes t square minus 3t plus 2. And now in the denominator, there is no problem. We can directly substitute t as 1 here. If you substitute, you'll get 3 plus 3. So 1 over 6 limit t tends to 1. Remember, this is not allowed to do the direct substitution, but since we know that limit will exist based on the options, so we can do this step just to save some time. So t square, t minus 1, t minus 2, factorization of this, and then 1 minus t, 1 plus t. Cancel this, you'll get a minus extra. So now just substitute the values. Minus 1 over 6. And then if you substitute here, you'll get minus 1 in the numerator divided by 2. So 1 over 12 is the answer. Option C. Question number 8 is one of the most commonly asked questions in JEE Mains and very important category also. It is given that it is a quadratic equation ax square plus bx plus c equal to 0. So definitely a is non-zero. And the roots of this equation are alpha and beta. So there are many conclusions that we can make. Sum of the roots, product of the roots. But which one of the conclusions will be relevant to our solving of the problem? We can see the limit that has been asked has an x minus alpha terms. So how will we write this as? We can easily see we can write this equation as a x minus alpha x minus beta. This is what we will be using to solve our problem. So let us see what is the limit now. Limit x tends to alpha 1 plus ax square plus bx plus c and then raised to 1 by x minus alpha. We can clearly see this is 1 raised to infinity form. If you put x as alpha in this, it will be 0 because alpha is the root of this equation. So how to solve these questions of 1 power infinity form? It will be e raised to fx minus 1. This is fx. The base is considered as the fx. Fx minus 1. If you subtract 1 from this 1 will get cancelled. So what will be remaining? Ax square plus bx plus c. And then times gx. This is the gx. The power is the gx. Times gx means it will be x minus alpha. So this will be e raised to limit x tends to alpha a x minus alpha x minus beta as discussed earlier, and this will be x minus alpha. E raised to a alpha minus beta. So which one is the correct option? Option C. Let us see the ninth question. Let us see this question. So if we multiply these powers, we'll see it is x power n raised by x power n divided by e raised to x. So limit x raised to infinity, x tends to infinity. We will try to convert it in entirely one variable form. So we can write it as x power n by e raised to x minus 3 x power n by e raised to x. Now this e raised to x I can transfer in the denominator. So this will be x power n divided by e raised to x. Now x power n by e raised to x, let us consider this as a new variable, suppose t. So x is going towards infinity. So how will these two change? Exponential is a much larger one. E raised to x is always like it increases at a faster rate than the algebraic ones, x raised to n. So this t will go towards 0 because the numerator will be vastly smaller than the denominator. So what will this limit become now? T tends to 0. This will become 2 raised to t minus 3 raised to t divided by t. Now I think it is clear which identity you will use. You can definitely do the L'Hopital. You can also do limit x tends to 0 a power x minus 1 by x, whichever is convenient. This will be 2 raised to t ln 2 minus 3 raised to t ln 3. So ln 2 minus ln 3, ln 2 by 3. Let us solve the 10th question. X tends to infinity. So e raised to x ln 1 plus ay by x minus e raised to x ln 1 plus by x by y. So we can clearly see there is an ln here and there is an e. So we can simplify this. If we simplify this, we'll get us this ay by x raised to x minus 1 plus by x raised to x divided by y. Okay. So we'll again so here and here in these two, we can again say it is 1 raised to infinity. So how we'll solve these two limits? Again, e raised to fx minus 1. So ay by x and then times gx. Times gx is x itself. Minus here e power by by x times x divided by y. Okay. So there is again one more limit here. After solving this for x, you have to again solve this for y. Y tends to 0. In all of that, there is a limit y tends to 0. Okay. So this has been solved for x. So now this becomes a limit in terms of y. So e raised to ay minus e raised to by divided by y. Directly we can use L'Hopital. So if you use L'Hopital and solve, you will get it as a minus b. Okay, a from here and b from here. So which one is the correct option? Option B. Let us see the 11th one. They have told you to draw the graph of this function, and the equation looks something like this. The function is itself a limit x over t square. Okay. So what if x is positive? Always the inverse trigonometric functions tend to behave differently for positives and negatives. At least the cot inverse does that. So if x by t square is going to 0. So t is going to 0. T is going to 0. So where will this go? This will go to infinity. So what will be fx in that case? If we approach this function to the point when x is positive, then this x by t square goes towards positive infinity. And what is cot inverse? That will be 0. So 2x by pi times 0. So 0. And what if x is negative? Then x by t square will go to minus infinity. So what will fx become in that case? It will be 2x by pi divided by 2x by pi times pi. So 2x. So fx is 0 for x positive and fx is 2x for x negative. So how will the graph look? For positive x, it is 0. So like this. And for negative x, it is 2x. So here somewhere. Okay, which option matches this? C. Let us go to the next question. This is a conceptual question. 12. So gx they have given to be x minus greatest integer x. From our knowledge, we know this will be fractional part of x. F0 they have given to be f of 1. Okay. And what is h of x? H of x is f of g of x. So it will be f of fractional part of x. Okay. So where do the discontinuities arise in case of fractional part of x? Fractional part is perfectly fine as long as the numbers are not integers. So we can very clearly say hx is continuous for all x that are not integers. So let us see what happens in the case of integers. So let x is an integer. We can consider x is some n. So what will be h of n? H of n will be f of g of n. What is the fractional part of this? That will be 0. So it will become f of 0. Okay. Now let us look at the left hand limit. Let us go to n from the negative side of hx. The limit x tends to n minus f of fractional part of x. How will the fractional part behave when you go to n from the negative side? Let's say n is 2. So you are approaching 2 from the left hand side means it is still 1 point something. How do you extract the fractional part of that quantity? You subtract 1 from that, right? So we can write it as f x minus, we considered our n to be 2. So we are approaching this number from the left hand side. So how will we get the fractional part of that? From x we subtract the integer which is 1 less than that. Okay. It is 1 point something if you approach 2 from the left hand side. So from this number you subtract 1. So you subtract 1 less than this. So now what will be this? You have to put n here, n minus n plus 1. So this is f of 1. Limit n plus hx. So for this right hand limit, how to approach this? Now we are approaching n to from the right hand side. Let's say n is 2, you are approaching it from the right hand side, it is 2 point something. How do you extract the fractional part of that? From this you subtract n. So this will be x minus n. Okay. From the number x, you subtract the value, the integer. So that will be f of 0. Now in the question it is given that f of 0 is equal to f of 1. So that means the left hand limit and right hand limit are same. And this is also equal to the value of the function, which is equal to f of 0. So that means left hand limit and right hand limit LHL is equal to RHL is equal to f of n. So that means the function is continuous whenever x is an integer. We know that the function is continuous for non-integers also. So that means overall the function is continuous for all real numbers. Okay. So which is the correct option? Option is B. 13th one, let us see. Now they have given a limit is 3 and you have to find the value of the unknown quantity. It's very common type of question. A 1 minus x sin x plus b cos x plus 5 divided by x square. It is given to be 3. Since the limit exists, it should be in one of the indeterminate forms that we know. The denominator is 0. So the numerator should also be 0. Now what if you put x as 0 there? You'll get a plus b plus 5. This should be 0. This is the first condition that you need. So that means a plus b equal to minus 5. Now that we have established that this is in the 0 by 0 form, what we can do? We can do differentiation. We can use L'Hopital. Minus a x cos x plus sin x minus b sin x divided by 2x should be 3. Now if we put x as 0 here, still we are getting 0 by 0. Let us differentiate it one more time so that the x is vanished from the denominator altogether. So if you differentiate, you will get this minus a 2 cos x minus x sin x minus b cos x divided by 2. Okay. So now again we'll put x as 0 here. So if we put x as 0 here, then what are we supposed to get? Minus a 2 minus b by 2 equal to 3. Okay, so that means 2a plus b should be minus 6. Now you have got two equations in two unknowns. You have to solve this. You'll get a as minus 1 and b as minus 4. Okay. Next, again for the right hand limit, then again you have to solve this separately. Sorry. X tends to 0 plus 1 plus cx plus dx cube divided by x square whole raised to 1 over x. What is this format? This is again 1 raised to infinity format. So how do you solve this question? Again e raised to limit x tends to 0 plus fx minus 1 cx plus dx cube divided by x square times gx, so times 1 over x. Okay. Now this will be e raised to limit x tends to 0 plus this will become c plus dx by x, and in the question we are given that continuous, so this should be also equal to 3. So now if we see that numerator here, the limit will not exist if c is a non-zero number. It will become something by 0, some constant by 0, which will be undefined. But since we are getting a proper value here, so the limit should exist. So that means c should be 0. Once c is 0, if you see clearly, e power d will be equal to 3. So now we can find whatever has been asked in the question. Okay. So this will be minus 1 plus 4 plus 3. So 6. Which option? B. 14. Very straightforward question. We know that whenever a function is like divided in terms of rational and irrational, it will always be continuous only at those points where the two parts are equal. So it will be continuous when x square is equal to 1. So that means x is equal to plus minus 1. So which one is the correct option? Option C. 15. So fx is given to be this greatest integer of sine, greatest integer of x. And they are asking for 0 to 2 pi, at which point the function is not continuous. So let's say it is between 0 to 1. 2 pi means 6 point something. We'll have to go up to that, but obviously we'll go in parts so that we can get different values. So this will be what? Sine 0. So 0, greatest integer of sine 0. What if it is between 1 to 2? Again, it will be sine of 1, still 0. 1 means still in the first quadrant, 0 point something. Okay. If it is between this, sine 2. Sine 2 means cross the second quadrant, but cross the first quadrant, but in second quadrant still positive, still 0 point something, so 0. So similarly, you have to keep on calculating. This will be sine 3, 0. Now, as soon as you cross this boundary, 4 less than equal x less than 5, now you are properly in the third quadrant. Sign is negative, so minus 0 point something. Sine 4 will be minus 1. And up to this value. Yeah. So we have to find all the values up to 2 pi minus 1. Okay, so we can see only here the function is discontinuous. Everywhere it is continuous only at this point. So where does it break? It breaks at 4. So what will be the x and y coordinates? X is 4, and what will be f of 4? Greatest integer of sine 4. Sine 4 means what? It is in the third quadrant. So negative, so minus 1. 4 comma minus 1 is the point. Option D. Okay. 16. Again, a very conceptual question. So fx is given to be limit t tends to infinity 1 plus sine pi x raised to t minus 1. 1 plus sine pi x raised to t plus 1. Suppose x is positive. Suppose this quantity sine x entirely sine pi x, not even x, let's say sine pi x is positive. Then 1 plus something positive, and that if you tend to infinity, the power, if you tend to infinity, any number that is 1 point something raised to infinity, it will go towards infinity. So how do you solve an infinity by infinity kind of thing? You can use L'Hopital, but since we have powers here, we'll divide this quantity by the 1 plus sine pi x raised to t. Okay. So first of all, let us write the very basic one. It will be 0 if x is an integer, if x is n. Okay, 1 minus 1 by 1 plus 1. Now, if sine pi x, if sine pi x is positive, then how do you solve? It is infinity by infinity. We will divide by 1 plus sine pi x raised to t in the numerator and the denominator. So 1 minus 1 by 1 plus sine pi x raised to t divided by 1 plus 1 by 1 plus sine pi x raised to t. Okay. And what if sine pi x is negative? What if sine pi x is negative? If sine pi x is negative, then this quantity itself will go to 0. So no need to do something, anything here, so 0 minus 1 by 0 plus 1. So what is the function now? It will be 0 if x is an integer. Okay. It will be 1 here because here both of them will become 0. 1 minus 0 by 1 plus 0 is 1. When sin x is positive, when is sin x positive? When the angle is in the first two quadrants. What is the general form of the first two quadrants? 2n pi and 2n plus 1 pi. Okay, 0 to pi, 2 pi to 3 pi. So 2, 3, 3, 4 and so on. So even odd. And then minus 1 if it is in the consecutive other two quadrants. How to represent them? 2n plus 1 pi starts with this and then 2n plus 2 pi. Okay. Okay. So 0 if x is an integer, 1 if x belongs to, we can cancel the pi here. So 2n plus 1 and then minus 1 x belongs to 2n plus 1 to 2n plus 2. We can clearly see the sign symbol of 1 is positive in the first part and negative in the first part. It depends on these two. If it is even, it is 1, and if it is odd, then it is minus 1. So we are trying to relate it with the intervals, any one end of the interval, so that we can write it in a simpler form. So even 1 and odd minus 1. What is the best way to represent that? It is minus 1 raised to n. And then in all both the two intervals, you can see the integers are consecutive. So we can write x belongs to n plus 1. Now if n is even, it will be 1, which is correct. Even 1. And if n is odd, then this will be minus 1, which is also correct because it is minus 1. So it is a compressed and easier way to write this function based on the pattern. So what will be the discontinuity of this? It will be discontinuous at all integer values. At all x belongs to z and p. Let us see the 17th. So they are given a function and they are asking for the continuity and the differentiability of this function. Not very difficult to check. Fx is equal to square root of x, 1 plus x sine 1 by x, x is positive, minus square root of minus x, 1 plus x sine 1 over x, x is negative, and 0 if x is 0. Let us check the continuity first. So what will be the left hand limit? Left hand limit will be limit x tends to 0 from the negative side, and we have to take this part of the function because this is the part where it is defined for negative x. So minus square root of minus x, 1 plus x sine 1 over x. So what will be this value? If you go to 0 from the negative side, it is minus 0 point something. So this will still be 0 point something, right? And this one, this will be 1 plus 0 times a number which is between 0 to minus 1 to 1. What is sine 1 by, what is sine 1 by x? If you put x as 0 there, then it is sine infinity. It is a number which is from minus 1 to 1, but a finite number between minus 1 to 1, oscillating. And then multiply it by 0. Obviously, it will be 0. Overall, this will come out as 0. Right hand limit will be the same case. Will still be 0. So continuous at x equal to 0. For differentiability, this is very simple. Let us look at the left hand derivative. Left hand derivative itself gives you the answer. Limit h tends to 0, f of a minus h. So f of minus h minus f of 0 divided by minus h. Okay. So this will be limit h tends to 0 minus square root of h 1 plus h sine 1 over h divided by minus h. Definitely in the denominator, if you cancel this, cancel the minus and cancel this will be square root of h. Numerator is finite, denominator becomes 0. So this does not exist. So not differentiable. So continuous but not differentiable. So option B. Okay. Let us go to the 18th. 18th has a max min part. What is the easiest way to solve these kind of questions that have a max min part? By drawing the graph of the functions. Okay, x square, x minus 1 whole square, 2x, 1 minus x. And you have to draw for only 0 to 1. So let us draw. Fx equal to x square, fine. You have to draw only between 0 to 1. So I'm not drawing it entirely. Only between 0 to 1. X minus 1 whole square. How do you draw the graph of this kind of function? X minus 1 whole square. That's it. X square. Okay. Yeah. So you shift it 1 unit to the left, to the right. This is the boundary. 1. Similarly, here this will become this. If you shift it, okay. This is generally y equal to x squared. Shift it 1 unit to the right because it is a minus 1 here. So you'll get this kind of a curve which is intersecting at 1. Okay. Now for 2x times 1 minus x, what will be the graph? It is 2x minus 2x square. X square coefficient negative, so it will open downwards. And then if you draw the graph, it will look something like this. Definitely intersecting 1 because it is a root of this equation. The roots of this equation are 0 and 1. You have to calculate the maximum value. That means at every point you have to see the highest part. Look at this point of intersection. This part of the graph is above. So we will discard this part. It's not even required. Similarly, this part also. Okay, this part also. At every point of intersection, you have to see which part of the graph is below. That you have to reject here and this. So what will be the graph of fx? It will be this. So two sharp edges and the 2 points in the graph. So how many points are there in which it is not differentiable? It is differentiable at every point. Everything is fine except these 2 points. So option C. Okay. Let us see the next question. 19. This is not very difficult. It looks difficult, but it is not very difficult. So fx is equal to greatest integer of x and then sin pi x. So they are asking this definition for minus 1 to 1. So let us see what happens when it is minus 1 to 0. X belongs to minus 1 to 0. So if x is between minus 1 to 0, then what will be the greatest integer? It will be minus 1 and then sin pi x. Again, you will get another minus 1 here multiplied. So it will become 1. And if x is between 0 to 1, directly the greatest integer is 0. So you will get overall 0. So which of the options is correct in this one? Continuous in 0 to 1, 0 to 1 also and minus 1 to 0 also. So option B. Let us look at the question number 20. So in question number 20, they have given fx to be greatest integer n plus p sin x. X is 0 to pi and p is a prime number. So again, we have to draw the graph of this. How to draw graph in case of greatest integer? At first, you have to draw the graph of n plus p sin x. And they are asking only between 0 to pi. So if you draw, you'll get something like this. Now in between 0 to pi, there will be some part of the graph in which this greatest integer will come out to be 1. So not good, not large enough to cross n plus 1. So there will be some portion here where the greatest integer will give you only the value n plus 1. Similarly, some part inside that interval 0 to pi will give you n plus 2. And this will keep on going. And here at this peak, what is this value? It is pi by 2. So sign will become 1. So this will give you the value n plus t. So now at all of these points, the function will be non-differentiable. So how many points are there that we have to calculate? Clearly, we can see the number of points in this part is equal to the number of points in this part. How many parts are there? How many points are there in the first part? There are p minus 1 points. And then in the other part also p minus 1 point, and this point is separate extra. So plus 1. So overall 2p minus 1 points. So how many points of non-differentiability? 2p minus 1. So option D. So let us end our discussion here. In the next part, we will be discussing the solutions of the other remaining questions. Thank you.